Hi, everyone. I'm Malhan Arif. I'm the founder and CEO of RelationalAI. We're a very distributed company. We have about 170 people in the company, with a lot of folks with engineering in various flavors in their background, including expertise in databases and programming languages and machine learning and operations research. So RelationalAI goes to market as a native app, or we like to say a co-processor to Snowflake, making it possible to augment Snowflake with reasoners of various flavors that help Snowflake customers get more out of their AI investments. So you need a combination of techniques to be able to answer important questions on behalf of business users. And so our insight is that infrastructure like that doesn't really exist, and that the best place to put that infrastructure is as close to the data as possible in data management technology, which is typically relational. And of course, we're doing the the combination of relational with AI. And so, being a creative bunch, we decided to call ourselves Relational AI. And in a way that was prescient because if a couple of years ago, AI became the thing to be in. And of course, generative AI models have introduced a new capability that we didn't have before that people are now combining with a variety of reasoning engines to solve the hardest problems for companies. If you want to answer questions like, how do I set up my Sony television and connect it to my Wi-Fi network? Or a question like, if you're a business person, how many Sony televisions did I sell a year ago? Okay, last May, for example. People today understand how to do that. The first question is sort of you're searching text documents and you're using something like RAG to find the bit in the documentation that explains how to set up your Sony television. The second question is usually answered with a text to SQL capability. You take the question, you generate a SQL query, and you run the SQL query on your relational database, and it tells you how many Sony televisions you sold last May. But things get more interesting in business when you want to, for example, know how many Sony televisions will I sell next May in Boston, and how should I price the Sony televisions so that I make the most money in Q2, or which warehouses have Sony televisions and which ones are closest to my store in Boston, because I want to make sure I get the TVs from the closest warehouse. Or when should I order more televisions from Sony to make sure I have enough inventory to meet the May demand. So all of these things kind of require more than a RAG system or a vector database or similarity search system or a SQL system operating on one type of data like text or tables. And so what we do is make it possible in a data cloud like Snowflake to integrate more reasoners that work across more data types. So the data types can be tabular, it can be JSON, it can be textual, it can be graph data, it can be image data, it can be data that's internal to the enterprise or sourced externally, for example, from the Snowflake data marketplace. It can be in closed formats or open formats, for example, an open format like Iceberg. And the reasoners can go beyond just SQL and similarity search to include rule-based reasoning, graph reasoning, predictive reasoning, prescriptive reasoning, so that you have a combination of reasoners working across a variety of data sets, so that you can take a hard-to-answer question and decompose it into smaller and smaller questions to get to the point where you can deploy these reasoners and across these data sets and get the answer to a hard business question. Okay, and this whole thing is coordinated with a semantic layer based on a knowledge graph, which has become a very popular thing, versus, say, semantic layers are also can be based on dimensional models, which are also popular. Semantic layers based on dimensional models are used more for BI and analytics, and semantic layers based on knowledge graphs are used more for applications and for doing, answering high value questions that make a big difference to the business. We've been applying and working with a few important customers, some in the telco. So on our website, you'll have AT&T, you'll have Blue Yonder, you'll have EY. We have other customers that we work with where they have had in very clunky, expensive, hard to evolve systems that were designed to answer just one or two of the questions that we just talked about, written in hundreds of thousands of lines of Java code or C# code, or in some cases C++ code. And we've been able to migrate them to this new kind of semantic layer technology based on relational knowledge graphs, and put them in an environment where these reasoners are available to that semantic layer, and get them to solve really hard problems in supply chain, in telco fraud, in accounting, and in particular in tax accounting, and other really hard problems like that. And so we see typically 20x, 30x, sometimes more reduction in systems complexity as measured as by lines of code, for example, where we've taken some applications that were written 800,000 lines of C# becomes 15,000 lines of relational knowledge graph. Or in the supply chain example, we gave a talk not too long ago about taking an application that had its business logic expressed in 205,000 lines of C++, and we made that about 8,000 lines of knowledge graph. So you get this sort of amazing reduction in complexity, which means that these types of questions can be answered much more cheaply, much more powerfully, more accurately, and the systems that underlie them can evolve very quickly with the business, and people can become more agile and more profitable as a result. It's been amazing, really, for me to see how the world has evolved to the point where you can, in a conversation like this, or in a business conversation, talk about ontologies or knowledge graphs or reasoning, and have people be interested. A few years ago, when we were evangelizing this stuff, people would be like, "Oh, don't use those words." And of course, you have very successful examples of companies in the AI space, both in terms of the infrastructure providers as well as people who develop applications. So infrastructure providers like OpenAI and Anthropic are talking openly about reasoning and having language models that do reasoning. DeepSeek was in the news as a language model that reasoned. 2 years ago, people were asking me, what is reasoning? What does that mean? Or companies like Palantir or ServiceNow are going to market with knowledge graphs and ontologies, and they talk openly about it, and they talk about why it's so important, and you can't have effective AI in the enterprise without these types of things. Also Glean, also Writer, many companies, including our customers now, who are starting to differentiate themselves in their markets and their industries by talking about knowledge graphs, ontologies, reasoning, all in the context of generative AI being able to mix and match these techniques to answer really important, really hard business questions. So yeah, that's definitely a trend we welcome, and we're just very happy that the world has caught up here a little bit, and that we have something to contribute to the success of AI moving forward.